All right. So the trigonometry you saw in grade 10 and 11, and I don't know, like in grade 10, that's when you cover most of it. I don't know if that's when the pandemic started for you, probably. So I'm gonna kind of go over that a little bit and make sure you understand before we start some of the prior concepts that I need you to know. Okay. So here we go. In grade 10, write this down. Grade 10 and 11, you used trig, and the trig you used most likely, or your teacher usually would have mentioned SOHCAHTOA. That probably rings a bell. Sine, cosine, and tangent, right? So I'm reading it out so you can. So in grade 10 and 11, you use trig to solve for sides / angles given a right triangle. And what do we know about right triangles? The definition is really you need one angle in that triangle to measure 90 degrees, and that's denoted by that little square in one of the vertices, right? One of the corners. So that right there tells us that that's a right triangle. So Pythagorean theorem and the SOHCAHTOA works for right triangles. So in grade 12, we will explore all types of triangles. So if you see the word oblique, which you're going to see multiple times, an oblique triangle is really a non-right triangle. So if you think of triangles, anything that doesn't look like it has a 90-degree angle is called an oblique triangle. If you have a highlighter or something to underline, probably be a good idea. And so the first, this is not your regular trig. We're going to talk about sine law and later on cosine law. And these two work with any type of triangle, okay? And watch this. Since we are working primarily with oblique triangles, we will not be using the primary trig ratios. SOHCAHTOA will not work in most cases. Do not use them. So if you remember SOHCAHTOA, 99% of the time it's not going to work for you. So I would just not use it, because what I'm going to teach you works for every scenario, oblique or right triangle. Okay, and that's all for this page. Let's go on to some previous. Okay, so these are the things that you should already know at this point, right? Sum of interior angles is always 180. I use this a lot. Sum of triangles is equal to 180. It's saying the same thing. Isosceles triangle, two equal sides, two equal angles. Do you know what the other word for equal is? Congruent. Does that ring a bell? Congruent. I think I talked about it earlier when we reviewed. So one thing that I don't want you to be stuck on is that an isosceles triangle always has to look like this, and where these two are equal, I'm actually going to do this. I'm going to make this side equal to that side. So which two angles are going to be the same? The angles that are right across these two sides. Equilateral, three angles, three sides that are all congruent. And so all three angles, because all sides are the same, all three angles will be the same. And then obviously your right triangle. And what's the longest side always called? Across the 90, that's the longest side? Hypotenuse, yes. So a couple of things there. Make sure, yeah. Alyssa, do you want to, Eliza, sorry, want to grab that? And then just pass it back. And here's the supplementary angles. It's a pretty basic concept, but a lot of students somehow don't see it in certain instances. But supplementary angles, really, it's two or more angles that add up to 180 degrees. Okay, so the classic is just a straight line. If you have a straight line and you pick any point on that line, so I will pick the middle here, right? And if you were to measure the opening from this side all the way to the other side, that is 180 degrees, right? A straight line. So a straight line has 180 degrees, so that's just the way it is. And if you were to make another one here, another straight line like that, and we're going to have another vector coming out of it. If I told you that this angle on this side is 150 degrees, could you tell me what this sliver would be on the other side? Oh, I have to put a little higher up here. What would this be? 30. Exactly. Right? These are two angles that are, we would call them supplementary. Two ways you know they're supplementary. They add up to 180 and they are along a straight line. They are along a straight line. So I'm always going to highlight the straight line there. And then one last example of supplementary angles. Make a triangle like this. Okay. And you can tell that this angle, what do you call an angle that is bigger than 90? Anybody remember? Obtuse, right? I can't read lips anymore because the masks. I used to be able to. So if I told you that that's 110, and you had a dashed line extending, so the baseline is just being extended, what would this be over here? 70, right? Okay. So these two angles here are effectively supplementary as well. Okay. So you can have supplementary angles combined with a triangle, right? So what about here? Notation. I'm just going to talk about the fact that if you want to talk about, if you have a triangle, if you want to refer to this angle right here, so angle A in this case, we have at least two ways to refer to it. Okay? So you could say angle A, or you could say angle BAC, the three-letter notation, which a lot of us do not like, right? BAC. So you go angle symbol, BAC. As long as A is in the middle, it doesn't matter. So another one would be, if you started from this side, it's CAB. All three of these are talking about that angle right there. And this is where the three-letter notation is going to help you. Is it all done? Okay, thank you. Look at that. Everybody? Did you see it? Did you all see it? It's not that hard to pass a piece of paper up and down your row, is it? Okay. Oh my goodness. All right. Here, if you had something like this, this is where you run into problems. If you wanted to refer to this angle on this side, I'm going to use a different color for it. If you want to talk about that angle right there, could you say just angle A? Would that be good enough? No, because A has basically two sides to it, correct? A has two sides to it. So if you want to talk about the red part of that of angle A, you would have to use BAC. So this angle would be called BAC. And this side would be called CAD, or you could say DAC. It doesn't matter as long as A is in the middle. Oops. Okay. So that's where the three-letter notation is basically your only option. Okay. Angle of elevation and depression. So consider this person. It always has to start with a horizontal line. So let's imagine that at this height we have our horizontal line. if you were to see a bird, or you look up at a tree, or you look up to a plane or a kite or a mountain, the angle formed between the horizontal and the line of sight, right, that is called the angle of elevation. You're elevating, right? It's going up. So this angle right here is called the angle of elevation. And so if you were to look down, so if this is the ground here, and there's a critter, a bug here, and you're looking down to something, that angle there is called the angle of depression. Do you remember that from grade 11? Vaguely. I want to know if you heard of it, right? That's all. Angle of depression. Oops, sorry. There's the angle of depression. Okay. And this is, yeah, I'm just going to give you an example where angle of depression would be wrong. Okay. This is a classic common error. So just underneath it, if some students give them a triangle, and I tell them, hey, label the angle of depression on this triangle, where do you think they'll put it 99% of the time? Unless I taught them, of course. Just saying. They will put it here, right? Because, hey, it's like this is the line going down, so angle of depression must be there. But is there a horizontal line involved here? No, right? So you technically have to do this. This is the angle of depression. Wrong, right? This would be wrong if you put it in there. It's actually here. And this, could you call this an angle of elevation, folks? This here? Would you be able to call that an angle of elevation? Is there a horizontal line involved? You bet. And a line going up, right? So this is the angle of elevation. So do not put the angle of depression in there. That's basically the most important part, right? Of this. Very good. Okay, so I'm going to leave the keywords for now. I'm not sure, I added that just before this started, and I'm pretty sure they will come up as we go along. So on page 260, a couple of things, right? It says that using trig ratios, sine, cosine, tan, as well as the Pythagorean theorem, can solve for missing side lengths and angle measures in a right triangle. But what happens if you know or want to know a missing measurement from an oblique triangle? Then we have to use the sine law, right? We use the sine law when it's oblique, right? You can solve for unknown side length or angle of an oblique triangle in certain situations. But I will say this: sine law also works with right triangles. So it basically solves the problem. If you were struggling with trig up until now, well, this is kind of like you can redeem yourself with this unit, right? You can start over again. If you never got the concept of SOHCAHTOA, right? Here it is. So basically, before I start with the formula, which you should have on your study sheet, right? I will just say this: capitals refers to angles, and lowercase side lengths. Okay, just remember that. And the conventional way, usually if capital A is here, that's the angle you're talking about. So they will label it outside the triangle, but they're really talking about this angle. The side across from it, I encourage you to do that. Arrow going right across, it will have a lowercase a right across from it. So when you're saying this is capital A, this is my angle A, then we know automatically that side A will be across from it. And so capital C will have lowercase c, capital B will have lowercase b across from it. Okay. I will also tell you this. The longest side in a triangle will always be across the largest angle. In a right triangle, the 90-degree angle was always the biggest angle in your triangle. And what's the side length that was across from it? It was always the hypotenuse, correct? It was always the longest side. And so the shortest side, this is actually a neat property because you can double check your answers, right? The shortest side will be across the smallest angle. That's just a property. Okay. That's all I'm going to say for this page. So let's go ahead and put this in practice. So before you flip, I just want to show you this formula, which is kind of like, why are they two equal signs? Like, what's going on here? The proof of this law is saying that if you take the sine of angle A and divide it by its side length, right? If you take the sine of this and divide it by the side, it will be exactly the same as taking sine of angle B and dividing it by the side length across from it. And it will also be exactly the same for these two. So there's basically three pairs. If you were to do this, it would always work out. Okay, we're only going to use one equal sign ever. Okay, we're not going to have two equal signs when we do our work. So let's go over to our first example. So today we're only going to learn how to solve for a missing side. Okay. Have your calculators ready? Okay. Listen carefully here. Okay. I'm going to already get you ready for the fact that at some point we're going to do cosine law. Okay. So I want you to scratch this. I want you to use the sine law to calculate. I just want you to calculate the length of side A. Obviously, at this point, we're only going to talk about sine law, but I will tell you how you know immediately that it is the sine law. This is the only thing you need to look for. You need to look for a pair, meaning you need to know the angle and the side length across from it. So I will do this. Okay. You have a known angle side pair, right? If you notice that, you say therefore, the three dots stand for therefore, use sine law. That's it. Like, as soon as you notice that, you know it's going to be a sine law situation. That's a prerequisite for you using the sine law. And that is the pair you're going to start with. Okay? So I'm going to start with that pair, and I tend to start with the angle on top, even though it doesn't matter. But sine of angle 52, so sine of angle B, is going to be divided by the side length across from it, which is 16.8 centimeters. Okay? And that is going to be equal to, in this case, I know I know the angle A here, right? I know angle A. If you look at the triangle, you know that. So I'm going to use sine of 72 and divide it by A, like that, because that's the side length across from 72. You cannot just say, sine of 72 divided by C, for example, because it's not accurate. It has to be angled across from the side. So this is your setup. That would be worth 1 mark. That's how I'm going to mark this. And then you cross multiply and divide, right? So you start here, cross multiply and divide. So it's really sine of 72 times 16.8 divided by sine of 52. And now we're going to have to make sure we all have our calculators, first of all, set to degrees. If yours is set to grad or rad, you want to graduate, but you don't want grad on here, okay? Because that gradients is not what you want. So we want to make sure there's a D or a DEG or something at the top of your calculator. Anything else will give you a wrong answer. Yeah. Okay, then do you have a mode button? Okay, press mode. And I'll press mode again. And press number 1 for degrees. So mode, and then 1. Got it? Okay. Anybody else need help switching? You might have a DRG button, like a degree button. Just keep pressing it until it says degrees. Okay, careful here. Those of you who have, I might find who has one of those calculators and help you out. But here, this is what I do first, okay, folks? 16.8 times sine of 72. I tend to first put in the number, then multiply by sine of 72. I hit equal, and then I go divide by sine of 52, hit equal again. So you're supposed to get 20.28. And we're finding a side length, right? So that means you have to have centimeters attached to it. That's your answer. Okay. If you're not getting this, please let me know. Maybe not, if you don't want to talk to me now as I walk by, like, let me know, I'll help you, okay? I know there's always issues with calculators, and I can figure it out in probably 5 seconds, so it's all good. Okay, now let's take it a step further, okay? Add another question here. Calculate the length of side C. What if they wanted side C? How would we do that? I'll tell you this, always start with the pair that the question gave you. So I'm going to say, okay, I'm going to figure the rest out, but right now I'm going to just say sine of 52 over 16.8 centimeters is equal to, what's the problem with side C? Let's go up to the triangle, because you need to understand this. Do you know either one of them? So you have a bit of a problem there, but for now I'm just going to write it in anyways. I'm just going to say sine of C over side length C. Make sure that angles are always glued to either sine or cosine. Never just put a 52 just randomly in there because it's going to be wrong. Okay, degrees cannot just show up like that. Okay, I know how to find C. Angle C is going to be, how many angles do I know in that triangle? I know 2, correct? So I will use the property that all angles in a triangle add up to 180. So I'm just going to go ahead and subtract 52, and I'm going to subtract 72 from it. So that is what, 56 degrees? I have my key here, so I know that it's 56. Okay. So you had to do an extra step. I will tell you, like, this is the property that I used. Like, if you want an explanation, sum of triangle is equal to 180. That's what I used here. And now I know C, right? Now I can plug this in to that and finish the calculation there. So it's sine of 56, and these angles could have decimals, so don't let that throw you off. But I need to make sure you understand we're not rounding early here. You're not going to round to 2 decimals along the way. You wait right till the end. So cross multiply and divide. So C is going to be 16.8 times sine of 56 divided by sine of 52. So here it is, 16.8 times sine of 56. I always hit the equal button just to make sure. Divided by sine of 52. And that's 17.67. And we are in centimeters because I'm trying to find a side length. Just do a quick check though. You got this? Okay. Just to not trust your answer blindly. Go up once to your triangle. Which one is because I know C is 56 degrees. So which one is the largest angle? It's this one, right? What's the side length across from it that we solved for? It's 20.28, right? This side over here is 1767. Is the longest side across the largest angle? The answer is yes, okay? And the shortest side is across the smallest angle, so check. Just do a quick check and then you know. And one more thing. We solved the triangle. Okay, what does that mean? We calculated all sides and all angles. That's what solving a triangle means. Okay? All sides, all angles. So if you wanted to do an inventory here, right? Angle A was 72, angle B was 52, angle C is 56. We found that one. A was 20.28 centimeters. B is 16.8 centimeters. C is 1767 centimeters. And I found these ones. I found that one. We found that one, and we found that one. So how many pieces did I need to have in order to solve for the other 3? You need 3 pieces of information, okay? Otherwise, you cannot do it. Okay. So sometimes you're going to have to find extra angles in order to actually solve. Okay. So let's go to the back side here. And I want you to make a modification here. It says calculate the length of the indicated side. I want you to scratch the indicated side. And I want you to write down all sides. I want you to solve for each triangle. There are two sides, right? So for this first one, they tell you, hey, find Z. And you can start with that one. But what would we call this side here? What letter would it get based on this triangle? X, right? Because capital X is here, so this is lowercase x. So I want you to find, you can start with the one they already told you to find, but once you're done that, I want you to also find the second side for all three, okay? And then I'll take it back towards the end, and I will walk around and make sure you are all understanding this. So how about we double check and make sure we get that right? So here you are given a pair. I would circle it and then start with it. Okay, so sine of 132, no talking now, 1794.3, right? And here you have a decision to make. As soon as it's not going to be so obvious. Okay, so I notice that Z is given to me. So I'm going to go sine of 15. Across from it is lowercase z, which is already labeled. I want to make sure you understand that sine needs to be there. Some of you are just putting the angles in there. And you're like, no, I understand today, right? But you're going to go looking back at your notes and you're going to forget that. So make sure you get that right. The setup is 1 mark. Then the next is actually showing what you're doing. So sine of 15, right? Multiplied. You have to show that step like this. I would like to see that, okay? And then you give me your answer. So there are 3 lines basically that you need to go through before you state your final answer. This is 624.91 meters. Clearly indicate what that is, okay? And then you can tell that you don't have angle X yet because you needed to find lowercase. So I want you to show me that work. Angle X is 180 minus 132 minus 15, right? Because that's going to be worth 1 mark. So X is going to be 33, right? So that is also worth marks. Start. I need you to understand this. You technically have this pair, and yet you actually have a second pair that you know, correct? Because you found Z. So technically, you have this pair as well, but I would not use it just in case you made a mistake. I would go back to the original, set it up like this, and then now I need to find, I already found X, which is 33 degrees, lowercase x there, cross multiply and divide, but I'm not just going to say equals, right? I'm actually going to show my work. Divided by sine of 132. And then you get 1315.01 meters. I would strongly encourage you to finish this whole page so that tomorrow I can just quickly show you the answers and you know where you're at. You need to figure out your calculator. For ACs and quizzes, I'm going to be picky on how you show your work, okay? So even though you're getting that number on your calculator, if you want full marks, you got to have all of those components, okay?